Welcome to the new session of mensuration. You have already learned that area is the region enclosed by a closed figure. Now, today we will be learning about the area of a rhombus, trapezium and general quadrilateral.
Rhombus is a special quadrilateral whose all four sides are equal. Opposite sides are parallel to each other and diagonals bisect each other at right angle. Now let's find the area of rhombus. Let's consider a rhombus ABCD. So area of rhombus ABCD equals to area of triangle ABD plus area of triangle BCD. Area of triangle equals to 1 by 2 into base into height. Therefore, area of triangle ABD equals to 1 by 2 into BD into H1 and area of triangle BCD equals to 1 by 2 into BD into H2. Let's take out common factor 1 by 2 into BD from both the terms and we get 1 by 2 into BD into H1 plus H2. H1 plus H2 equals to AC. So we get 1 by 2 into BD into AC. Now BD and AC are the diagonals of rhombus. Therefore, we can generalize and write area of rhombus ABCD equals to 1 by 2 into D1 into D2. Or we can say area of rhombus ABCD equals to 1 by 2 into product of two diagonals. Students, since rhombus is also a parallelogram, we can also find the area of rhombus as area of parallelogram, which is equal to base into height. Here, base is the length of the side of rhombus. Let's understand the application of this formula by solving a question. Find the area of rhombus ABCD shown in the figure. We are given length of diagonal AC equals to 18 cm. Length of diagonal BD equals to 10 cm. And we know area of rhombus ABCD equals to 1 by 2 into D1 into D2. So let's put the values and we get 1 by 2 into 18 into 10. Simplify it and we get area of rhombus ABCD equals to 90 square centimeter.
And a trapezium is basically a four-sided shape, so it's a quadrilateral with one pair of parallel sides. And in this case the parallel sides we've labelled A is that top one and B is the bottom one. Now the only other letter that we use is H, that is the perpendicular height. Now it's not the sloped height, it has to be the perpendicular height of the trapezium. Now just imagine that we were able to slice our trapezium in half. So we're going to cut it in half with a pair of scissors along that line there. Now we're also going to do something else. We're going to put a little hinge at that point there. So just imagine we can flip this whole top half of our trapezium that we've just sliced along this line, and we're going to flip it, rotate it on this hinge, on this centre of rotation if you like. So we can do that by moving this slider, and there you go, we're just flipping our top half of our trapezium all the way around gentle thud, it hits the bottom, and now we actually have a parallelogram. So if you just look what happened to length A at the top there, so here's our length A, it's actually now moving all the way to the bottom down here. Just watch where length A goes, so it's actually going all the way to the bottom, so I'm going to move it down here. Now, next I'm going to take this little bit at the end away, and I'm going to move it all the way to the other end. It's going to slot perfectly in place there. So now we actually have a rectangle. We can still see where our top half of the trapezium has fallen into, but basically we have a rectangle with the length is A and B, and our new height is half of H. So we can put half of H there, and everyone knows how to find the area of a rectangle. It's just length times width. So the area of a trapezium is half H times by A plus B. Fantastic.
Let us try to solve an example. The shape of the top surface of a table is trapezium. Its parallel sides are 1 meter and 1.4 meter, and the perpendicular distance between them is 0.9 meter. Find its area. Let's start getting the answer. We know the area of a trapezium is got by using the formula half into h into a plus b. Here, height is 0.9 meter, a is 1 meter and b is 1.4 meter. Substituting these values in the given equation, it is changed as half into 0.9 into 1 plus 1.4. Adding 1 and 1.4, we will be getting 2.4. So we can write it as equal to half into 0.9 into 2.4. When we cancel that, we will be again simplifying and we will get it as 0.9 into 1.2. And multiplying that, the final answer is 1.08 meters squared. So hence, the area of the top surface of the table is 1.08 meters squared. Now let us take the case of finding the area of a general quadrilateral. Here, as you see, ABCD is a quadrilateral. As you know, quadrilateral means it is a four-sided closed figure. And here BD is the diagonal and H1 is the perpendicular from the vertex A. H2 is the perpendicular from the vertex C. Now, to get the area of the quadrilateral ABCD, there are two triangles. We need to get the area of both the triangles and add it. So the area of the first triangle is half into DB into H1 plus the area of the second triangle, that is half into DB into H2. That's equal to half into DB is taken common into H1 plus H2. Here, as you see, DB is the diagonal. So we can replace DB with the letter D. So the final answer for getting the area of a quadrilateral equals half into D into H1 plus H2. Here we have an example where the diagonal is 10, H1 is 5 and H2 is 7. We apply the formula area equals half into D into H1 plus H2. So that's equal to half into, in the place of D it is 10 into h1 is 5 and h2 is 7. So it comes as 5 plus 7. And the sum of 5 and 7 gives us 12. By further simplification, we will be getting the final answer as 60 square units. So that's how we get the area of a general quadrilateral. So children, today we have learnt what is area. That is, area is the region enclosed by a closed figure. Also, we have dealt with 3 different cases. The first was the area of a rhombus, which is equal to half into d1 into d2. That means it is equal to half the product of its diagonals. Now the second case was the area of trapezium, which is equal to half into h into a plus b, which is same as half into height into sum of the parallel sides. And the third case, that is the area of a general quadrilateral, which is equal to half into d into h1 plus h2. Thank you children. Have a nice day.